Let's answer some of these AP physics problem. The first question says that which of the following must be true if the net force acting on an object is zero? Now, what is the implication of the net force acting on an object to be zero? What that simply means is that we have F net equals zero. And generally, according to the Newton's second law of motion, F net is mass times acceleration. And since we're talking about an object here, it implies that mass, which is m, cannot be equal to zero. And since F net is equal to zero here, it implies that acceleration equals zero. Now, for acceleration of an object to be equal to zero, it does not necessarily mean that the object is at rest. Acceleration itself is simply the change in velocity. So whenever a body is moving with uniform velocity, that is, there is no change in their velocity, then acceleration, which is given as change in velocity divided by time. Since change in velocity, the velocity is not changing, then the change in velocity is going to be equal to zero. And that is what makes acceleration equals zero. Hence, a body can be moving as long as they are moving with constant velocity, then they will not have acceleration. So, is the object at rest? No, it does not necessarily mean that the object is at rest. Also, when an object is at rest, of course, the acceleration will be equal to zero. That is a trivial case. But generally, it's not necessary that acceleration is going to be equal to zero because the body is at rest. The body could be moving, that is moving with uniform velocity before the acceleration equals to zero. And Roman figure 2 says that the object has a constant velocity. I think I explained that in Roman figure 1 already. That is true. If the net force equals zero, then acceleration equals to zero. And the implication of that is that the body is moving with a constant velocity. Lastly, it says there are no force acting on the object. This is not going to be true because what happened is that the net force is the one equal to zero. It doesn't mean that there are no forces acting on the object. For example, you could have a force of, let's say, 50 Newton acting from left to right, and you could have another force of 20 newtons acting from right to left, and a last force of 30 newtons also acting from right to left. When you look at it as well, very well, the action of the 50 newton cancels the action of the 50 newtons from right to left, and this net force is going to be equal to zero. So Roman figure 3 is also not correct. Hence, the only correct option there is option B, which says Roman figure 2 only. Now let's move to the next question. The next question says that an elevator has a mass of 500 kilograms. It may safely carry an additional mass of 1000 kilograms. So that implies that the total mass that will be involved in this motion will be 1500 kilograms of mass. And because this elevator is accelerating upward at a rate of 2 meters per second squared. So let's say this is the elevator. The total mass of the elevator that is acting is 1500 kilograms, and the weight is acting downward. So the weight is going to be 1500 multiplied by 9.8. Let me get my calculator to do that. 1500 multiplied by 9.8. That, so the weight, which is actually acting downward, is 14,700 newtons. And because the elevator is attached to a cable, as the weight is acting downward, there's a tension generated in the cable. The tension will be acting upward. The tension will be acting upward. So now we have two forces in this system. The weight that is acting downward and the tension that is acting upward. So when you find the net force of that, so you have T minus weight, which will be equal to the net force, and that will be the mass times the acceleration. So when you do this very well, you realize that tension minus 14,700 equals mass is 1500 multiplied by acceleration, that would be 3000. And when you solve for tension here, so tension will be 3000 plus 14,700, and altogether that will be 17,700 newtons, and that will be the total maximum tension under this condition. Let's move to problem number 3. Problem number 3 says that this diagram is the top view. This diagram is the top view of a stopper tied to a string and spun in a horizontal circle. So we have a horizontal circle like this. Which of the following would match with an object moving at point P in a counterclockwise direction? So it's spinning in this way, so all the movement is going to be like this. So permit me to get rid of this particular calculation so that I can explain there. Now, so what is going on here is that this body is spinning in counterclockwise direction, and it is in a horizontal circular motion. There are three things to notice here. We have the speed, we have the acceleration, and we have the net force. Now, acceleration and the net force, they are always going to be in the same direction, which is always going to be towards the center of the circle, towards the center of the, and since we are considering this P path, so that implies that the acceleration is going to be going arrow up, and the net force, which is the centripetal force, will also be acting upward like this towards the center of the circle. So that implies that the arrow up will be the sign for the first net force and for the acceleration. And the speed is always tangential at every point of the circle. At every point of the circle, the speed is going to be tangential. So if it is there, so the speed is going to be tangential to this place. And so if you look at that very well, the correct one that satisfies that, of course, is not option A, not B, okay, not C as well. No. The last option is the correct one there. So we have V, tangential, and then we have A and F net moving in the same direction. And that will be the correct option. I'll be stopping here at number 3. In my next video, I'll continue with the rest of the problem. I'll see you in the next one.